Okay, so I am going to, in this video, we are going to add the PCB layout and the PC104 bus connector. So I have opened the onboard computer. It's not complete yet, but we're just gonna do the standardization of the connectors. Basically, or rather specifically, the PC104 bus connector. So basically, we go to LCSC. I'll just open it in a new window here and search for that connector. Remember that we said the PC104 ISA connector is the standard connector that is used on rather in rugged designs like satellites. So PCBs that look like this have the PC104 connection that can then mate into the board that is below it. So this is the connector, the ISA connector I'm talking about. This is not very clear, but it's visible enough. So we are going to add this on our PCB. So on LC, we search for PC104. PC104 and the female headers, you should be able to see. Yeah, you should be able to see this version is 22 times 22 rows by 20 pins. So we're gonna place that, copy the number, come down here, Shift F, paste the part number and place the connector somewhere there. The next is this smaller version of the connector. We might not need it, but it's good to have, I think, for now. So let me just place it. Is this one right here. So this is still 2 times 20, but let me see, 40 pin, the same. Okay, let it remain that way. So there's this connector here. We will do the pinout configuration next time, but I think we can lay out the PC104 standard board just with these components. So I'll just quickly glance over the standard that I'm talking about. Open Paint. Yeah, Paint will do just fine. So basically for PC104, we have a board that looks like this, square for 1U. And then we have mounting holes on the edge, and then mounting holes here. And then the connector is placed right about there. This is not to scale. So this is the connector. Then you have your devices here. You can have your chip, motherboard, devices, sensors, whatnot, depending on what board it is. Now the next major thing is the dimensions. The distance from this point to this point has to be a specific length, and the distance between this point, one edge and the other edge, has to be a specific length. So for 1U, they recommend us to use 96 millimeters by around, confirm that, 96 by, what is it, 96 by 90 by 96. Yep, 90 by 96. So this is 90 here. Millimeters. Yeah, so basically 9 centimeters by 9.6 centimeters. So I'm just going to open this specification document, rather guide, and refer to it. So you can see the connectors are placed close to the connector, and then close to the connector on the top here. And then on the bottom side, they are on the edge, almost on the edge. Yeah, so 20 pin PCI bus. All right. So let's do that. So we come back to EZDA. We save this first and come to PCB. The next thing we do is go to design. There are a lot of things you can do here. You can check the design rules, check the DRCs, check everything. But right now we are only interested on the PCB dimensions. And that's what I'm going to do. So we just import the changes from schematic, and so that you can get the footprints of all the components that we have. We apply the changes, and yeah, we have very few components. I'm going to add one major remaining thing, which are the mounting holes. So you can come to common library and search for mounting screw holes, M3 basically. So I'll go with M3 and place 4 of them. Save that, come back to PCB, and we import design, update, the import changes. There's no difference. You can update or import changes. Apply that. So you see we have these screw holes. So I want to see how they look like first. 3D. Okay, so they look like these are 3 millimeters, 3mm screw holes. Okay. Now let's define the shape of our PCB. So if you look closely on other satellites that have been built, or new satellites, PCB boards, images, you can see this kind of this structure. This structure is the one that we are going to use. So it has screw holes on the edge, then corners with, I think these are around 2 millimeters radius, padding on the screw holes, and then there's this notch right here. I think it's half point, but that is defined by the launcher you're going to use, and also your mechanical structural frame. So I am going to have it for my PCB. And yeah, mechanically, I mean structurally, that's what I see. Then you have 2 ISA connectors. So you can see these ones I've used 40, these are 40 pins, depending on how much how much interface pins they need. All right, so another thing to note is that this mounting hole is closer to the ISA connector at this point than this. Yeah, so if you look closely at this image, you can see the distance between this point and this point is much more than this distance here. Okay, so they have told us that I want to look at this is supposed to be 2.36 inches. The distance or the length of the length of the connector. Okay, so that's enough information. So now next we go to layers, go to outline, no, board outline layer, and then we draw lines here. So you can draw a polyline, or you can draw a polyline, just a line here. And then what I want to do is change the thickness of this line. Thickness, line width. So let me change the dimensions for that. Press Q. So from mils to millimeters. Line width, let me make it this 0.2. Let me make it 0.5. Double. Yeah, double. Then the length should be, now I want my radius at this point to be 1 millimeter, which means if I have a curve at this point, at the corner here, this point is what I'm talking about. So I have a curve that is, forgive this, but whatever. This is 1 millimeter, and then this is 1 millimeter. So it means the straight line will be 96 minus 2, should be 94. And then another curve here. Yeah, like that. 94. Okay, so the length of this line should be 94 millimeters. Okay, so click on the line, then set the length to 94. Then you can copy paste this, receive, then you rotate it, but the length of this will be 90. This is 90 minus 2, 88. The length of this should be 88. Now what I do is I put an arc at this point here, such that I'll have a 2-point arc, center arc. Let me use a center arc first. Now, let me use 3 points. So this thing always confuses me. Okay, how to draw. So this 3-point arc is 1, 2, then the arc. Okay, the edges, then the arc itself. So point, then we do that. So arc length, there should be a point to set the arc length. It's not there, but we can measure. Let's measure this length from this point to around that point. It's 2 millimeters, too much. So we can make the arc smaller. Can make it smaller. And then the width should be 0.5. So let's confirm the width. It's 1.7, still it's a lot. So these are strict guidelines that you should follow for this application. Measure that again. There should be an easier way to do that, but it's 1.1. Tolerance of 0.1 millimeters is fine for this project. So I'll keep it at that and connect at that point. Okay, so we have like a smooth edge there. So what you can do at this point, I'll try copy this, which is basically this, that, and that. Then rotate it like that. And then I copy this part, bring it over here, rotate it, and place it carefully on the edge, just about there, but then I need to move it a little bit. Gray size is too big. Let me say 0.01, so they're gonna be able to move it finer. Okay, so that should be around there. And one last remaining thing, these two. So this should come there. This one should be, let me confirm that. Cool, around that point. And then lastly we paste this here. Like that. Okay. So alright. That should be fine. Now the next thing is we place the connector here. So I'll put it at the top. There are things to do with the edge to board clearance. I'll open this and check. This is not conclusive, but there's no dimension or distance between this point and the edge of the board. So I'll just eyeball it. We'll confirm the details maybe in the next video. So I place it around there. Should be in the center, but we place it there. Screw hole 1. Oh, let me change this first. The numbering of the screw holes. 1, 2. I think it's okay. Okay. So I'll place this somewhere around there. Next to the connector. And then this other one right about there. These two come down here. Around almost the edge of the corner of the board. This other one comes here. We will optimize these dimensions later, because you can see that we might have like offsets of around 0.1 or 0.5 millimeters or 1 millimeter. So we'll do that later, fixing. And then the next is just laying out the components. So I won't lay out the PCB yet because it's not done, but basically that's it about the PC104 standard. So this board right here follows the PC104 standard with a standard ISA connector, and let me rotate this, and the dimensions are set. So just to be conclusive, I can put a dimension here. It's 90.6. Tolerance is fine. And then this other one is around around what? 96.2 millimeters. All right, so that's all about the PC104 1U CubeSat PCB dimensions with a standard ISA connector. So remember that the ISA connector is a connector that allows you to intermarry basically the balls. If you look closely, you can see these lines are longer. They are very long so that they can like stack on top of the next board below it. Yeah. All right. So see you on the next one.